Okay, I would like to continue with the recursion topics. Let's review what we learned from last time, okay? Let's try to recall how we derived the solution recursively. Just review the way we did things, and then we'll see more examples. So over here, you see that we have done factorial, Fibonacci, is palindrome, reverse. So these are the four we did last time. I'm going to review the way we derived the solution recursively. And then let's try to see if we can apply the same principle to this particular example over there, a new one. And then we'll get more examples done. Okay? Okay. Okay, let's see how we can do that very quickly. Okay? Here's the thing. For recursion, the way it works is very similar to mathematical induction. You are given some problem to solve, but just cannot solve it right away. You have to assume you have solutions already to the strictly smaller subproblems. Okay, let's try to apply this same principle to different problems so you can really compare. The same principle applies for every recursive problem. Let's say over here, when we did factorial of n, so what can be the subproblems, right? Subproblem means, so now here you can see the problem over here, the size is n over here. So you can only assume you got solution to a strictly smaller problem. For example, in this case, we assume we got factorial of n minus 1. N minus 1 is strictly, oh, you don't have that, do you? Oh, that's interesting. You know what? Let me disconnect and connect again. Thank you for letting me know. Good. Let's try again, okay? I'll do that very quickly. Okay. Let's do it again. Quick time. And then, oops. Quick time over here, file. Quick time, file. Okay, let me do it one more time. What I really want to do is file, new movie recording. You know what? I might have a backup line. Okay, let's try one more time, okay? Okay, over here, file. I do not want screen recording. That's not what I want. Okay, let's try. Okay, let's try one more time. Quick time. File, movie recording. There we go. Okay, there we go. Okay, come on. Okay, so now actually it's a bit weird today. File. Okay, close the whole thing and try again. Okay, file, new movie, and then Pro. Okay, good. Very good. Now we got back. Okay, let's see if you can see that. Good, very good. Okay, back to track. Now, let's say we're trying to solve this factorial problem here. The original problem is of size n, and we assume we got solution to a subproblem, in this case n minus 1. What about for Fibonacci number over here? You can assume for as many solutions as you like, as long as they are solution to strictly smaller problems. In this case, what we did was we assumed we got Fibonacci n minus 1, Fibonacci n minus 2. So we assume two solutions over there. You can just assume for as many as you like. What about is palindrome P? I'm trying to make the problem a little bit easier for you. Let's say for every string, let's say in this string over here, we got the first character C1, we got the ending character C2, and then we got the middle string S. Okay, just make it easy. So you got this pattern over here. So now we can assume that you actually got is palindrome available for a strictly smaller string. In this case, we can say is palindrome just the middle string, in which case we take out the first and last character, right? So we are solving a smaller problem. So what about reverse? For reverse, let's say we have a string where we can decompose the string into the first character C1 and also the remaining string to be S over here. So now again, we can assume we have solution to say we can figure out the reverse of the tail S over here. Okay, so far so good? Okay, so now given these solutions here, you can see these solutions, you don't have to solve them directly. For these assumed solution, you can assume they are simply there. All you got to do is, you want to say for the original problem I want to solve, I can simply apply the solution I assume with some very simple arithmetic, and then I got it. Okay, how do I do that? For example, the solution for factorial n would be simply whatever n it is, multiplied by the solution I assume. And that's it. That's the solution. And what about for Fibonacci n? In this case, I assume this, I assume that. I can just add it up together, right? So I can have Fibonacci n minus 1 plus Fibonacci n minus 2. Okay, we just combine them together. What about is palindrome over here? So now you can see that if my friend, you can think of when you assume some solution, it's actually your friend who is going to do the job for you. Now, your friend is very generous, but they are not unreasonable. You cannot just give the original problem to your friend to say, now, I'm supposed to solve Fibonacci n. I will just ask my friend to solve Fibonacci n for me as well. No, that's not acceptable. You got to give them some problem that's strictly smaller, like n minus 1, n minus 2. Now, for is palindrome, how do we do that? I give to my friend the middle string over there to tell my friend to check for me if the middle string is a palindrome. They tell me either true or false. And then what I got to do is I'm going to take the first character and the last character and compare them to see if they're equal or not. I'll compare with my friend's solution, right? So this is how we do it. You can say C1 equals C2. That's the job from my side. And then is palindrome S is the solution from my friend. And then I just combine them using conjunction. Okay? So from my side, I should always do the minimum work. I do something that's very simple. And then I delegate all the job, basically a strictly smaller problem to my friend. Okay? What about reverse over here? Of course, you can solve reverse in different ways. But let's say for this particular case, now I can simply decompose my string into two parts. The first character C1 and the tail S. Now I can simply delegate the tail to my friend. And then once they get the reverse of the tail, what we can do is whatever reverse my friend give to me, and then I say combine this with the current first character. Once I get that, I'll get a reverse. Right? That's kind of the visual I showed you last time. Any question about how you can apply the same principle to different problems over here? It's like a summary. So in case you lost a big picture from last time, so here I'm just trying to show you again. You can see that what I'm doing here, I'm not really trying to write Java code. I think it's more important for you to understand how to solve the problem recursively. And then translating it into Java should be a piece of cake, I think. Okay, well, should be easier. Now, let's try this new problem over here. Let's go over the problem here on the slides, and then let's see how we can solve it informally. And then we'll see how the Java code looks like. Okay? Now, let's say this is a problem we are solving over here. Let's say we want to write a recursive method, or we want to solve the method recursively. It's going to take a string. So this will be our last example on string recursion. We're going to do a recursion on array in just a moment. Let's say the method is going to take a string and also a character. And then we're going to figure out how many times the character occurs in the string. Okay? For example, let's say over here, if you have simply empty string over here, we are asking how many times the character A occurs in this string over here. Well, in that case, simply 0 times, right? You can see that the empty string is a very special base case because it doesn't matter what character you give here, it's always 0, right? Because no character can be found in the empty string. And what about here? 1, right? Because A here occurs only 1 time in this string here, just itself, just over there. Just 1. What about here? 0. Very good. Okay, you kind of get an idea. I may get more example. Let's see. How about here? 3. Very good. Okay, you get the idea. Very good. You can finish the rest. Okay, now let's apply what we have learned. Okay, let's first think about what the base cases are. So in this case, what can you see as the base cases, which means problems that are small enough, I can solve them right away. I don't have to rely on my friends. For example, empty string. So for empty string, what do I return? Always 0. Doesn't matter what it is. Now, I agree. So one of the base cases of empty string always returns 0. Now, would there be another base case? Single character. Now, can I always return 1 on single character? So how should I judge? Just check it, exactly. So let's say a single length string is actually B. I'm checking for A. In that case, that'll be 0. If the single string is B, but I'm checking for B as well, then the result should be 1, right? Okay, so that really depends. In that case, we're gonna do some recursive case over here, right? Let's go back here. Let's try to apply into our solution pattern over here, okay? So now let's say the following. We are trying to solve this particular method here, let's say occurrence of. We're passing some string, and the string, just make it a little bit easier for you. Let's say the head of the string is C1, the head character, and the remaining string, the tail, is S. We want to check how many times C2 occurs in this string over here. Okay? So now, how do we do this? First of all, before you don't have a clue, we already figure out the base cases. Write them out first. Okay? And then, what about the subproblems? What kind of subproblems can we just delegate to our friend directly? Apparently, just the tail S, right? Okay, let's write it out first, and then we'll see how to combine them. In this particular case, combining them is a little bit more challenging. Okay, first of all, let's write out the sub-solution that we can assume. As long as the problem is strictly smaller, then we can assume. So we can say occurrence of, let's say here we got S over here, with the C1 taken out, and then the same character C2. So what this means is our friend can tell us the occurrence of C2 in S, but they don't know about C1. So now, so this is going to be some number, right? So how can we combine it in a way? Okay, let me give you one example before you say anything. How about this? Let's say this. If I have occurrence of, let's say, the first character, for example, is simply just A, and then I have AAB, something like that. Okay, let me just put a string like that. And then I have the character, let's say A. Versus, let's say another example, okay? Let's say I have B here, AAB, and then also A over here. Let's think about these two cases of calling the method. In the first case over here, the problem that we give to our friend is simply just AAB, right? The remaining part. So now, what would be the result for the recursive call? So our friend will tell us what's going to be the number of occurrences of A in AAB. In that case, just 2, right? So now, in this case, we know that it's going to be something like the occurrence of, so here we have AAB and also A. This is what our friend will tell us. In this case, that was simply just 2. Now, how do we combine this result into the final result? We know that the final result should be 3, not 2, simply because this first character here matches this one here. So we should say 1 plus. On the other hand, let's say in this case over here, our friend, again, is going to occurrence of, is going to give us the same result, AAB, and then A over here. Okay, it's also 2. But now in this case, we know the final result is going to be 2, not 3. So that means from our part, we contribute nothing. But how do we know that? It's simply because A is not equal to B. So we got 2 cases to handle. In that case, that'll be 0 plus. Okay? Any question about these 2 cases before I try to tell you what the solution should be? Yeah? Which one? Oh, the over 2. Okay. Over 2 simply means this part here returns 2. And this part here returns 2. I don't really mean over 2. I'm saying the recursive call that we rely on our friend is going to return 2. That's what I meant. And somehow we're going to combine this result with something else, right? Okay, so you can see that there are two cases over here. So if C1 over here matches C2, then we have to say 1 plus. If C1 does not match C2, then we're going to say 0 plus, just contribute nothing further from our friend. Okay? Okay, so what should we do over here? Okay, let me just, so this is only example. Let me just use a different color here. And now, how should we generalize this into, I'll put it here, okay? You can say that if over C1 matches C2, in that case, the solution should be, that should be 1 plus the occurrence of S, and then we have C2. Otherwise, it's simply 0 plus, whatever it is, right? Okay, you get the idea. I just ran out of space, but that part, the horizontal line over there should be occurrence of SC2. Okay? Any question about this before I show you the Java code? If you understand the idea, the Java code should be not too difficult. Okay? Showing you directly Java code is not the way to go. Okay? I think you better understand what's really the idea. Okay? You will find that this kind of solving the problem recursively pattern here can be applied to every problem you're going to solve, okay? Almost everyone, okay? Always think about what the sub-problems you can assume the solutions for, and then how you can combine the solution for the sub-problems there using some arithmetic, and then come up with the final solution, okay? That's kind of the process. Okay, let's go back here, and then let's see the Java code very quickly. Yeah, so here the text over here is basically just what I said. So now, let's see how we can define this method here. Occurrences of. What we do is, first of all, if the string is empty, always just return 0. Okay? Otherwise, we can first of all get a head of the string. That's kind of C1 that we talk about. Simply you can say char at position 0. And then what about the tail? Tail would be the remaining part, which would be from position 1 until the end. And then we say that if the C1 head and the C2, which is input C, if they match, then we can simply just say 1 plus. Otherwise, we say 0 plus. Of course, you can make it kind of cleaner if you like. I'm just trying to make them explicit. Okay. So that's the solution here. And then you can find the source code in the zip project made available online. Okay. Questions about this? Can I go to the next one? Okay. So far, we talked about how you can do recursion on integers, how you can do recursion on strings. And then next, we're going to see how you can do recursion on arrays. Okay? The idea about recursion on array is actually very simple. In some ways, it's fundamentally the same as recursion on string. Because for the case of the string, you have to focus on which character or which substring you're talking about, using char at or substring. In the case of the array, especially primitive array, now we're going to think about, if you want to get a first element in the array, that's easy. Just go to index 0. But how can you get a subarray over there, right? Naively, you might just want to create a new array and then copy over the n-1 elements into there and then pass that subarray into the recursive call naively. But that's very, very inefficient. A much better way is to actually somehow to say from which point to which point for the indices you want to really recur on your array. I'm going to show that to you. But I want you to have that concept first. But conceptually, it's really the same as string. We want to have some initial elements in the array and the remaining of the array, okay, to do the recursion. Okay, let's first of all, I want to talk about this method here. Okay, I'll do the first one in very much detail. And also, figuring out the base cases for arrays sometimes can be tricky. And you have to use some knowledge from 1019. But I will illustrate it to you. Okay, it's quite important. Okay, now, let's have a look at this problem here. I want to know if an array contains positive numbers only, i.e. if all the numbers are larger than 0. Okay, let's see that. Well, let's just see some example very quickly. Okay, first of all, a question for you right away. If I say the input is simply just empty array, should that be true or false? True or false? Empty. True? How do you know? No exception. Empty array is okay. Yeah, This has to do with the logic, which I will show you in just a moment. Okay? Can anybody explain to me why, for empty array, all the numbers are positive? The way you justify is a little bit tricky, I would say. But if you, since you took 1019, some of you can feel free. Yeah. Wow, that's impressive. That's exactly correct. So, okay, now, first of all, the empty array, in this case, we want to know if all the numbers in the empty array are positive. And the answer is true. Why? Because you cannot find any counterexamples, which means you cannot find any negative number that's not positive in an array. So that it's got to be true. Okay, now let's go back to your 1019. Let me just state this a little bit more properly. I'm pretty sure you have seen this. You have taken the course before. Okay, something like this. Now, let me just do a little bit warm up. If I say for every x integer, okay, I'll just use integer int over here, such that x is in the set 1, 2, and 3. It is the case that x is greater than 2. Is this for all? Is this universal quantification true or false? False, because which one can be the counterexample? What? Over here, right? Okay, just a warm up. Okay. Now let's consider extreme cases. Okay. Oh, actually, let me just do one more. You also know this guy, right? Exists. There exists x in integer such that, let's say the same range over here, x can be 1 or 2 or 3. X larger than 2. In this case, true or false? As long as you can find one witness, then that will be true. So this will be true, this will be false. Okay? That's only review. Okay? Let's consider the more general extreme cases. If I say for every x, anything, and then let's say x is in a member of empty set, and I give any property on x, any property. On the other hand, I say there exists x over here, x, also empty set, p of x. Okay, 1 and 2. Now, 1, true or false? Okay, so now think about why. So now we are saying that, think of x being any integer, or the integers in the array we are considering. Okay, now the array is simply just empty. Right? Now, the p of x, p is certain, just any property. The property can be if the number is positive, or if the number is even, or if the number is a prime number, things like that. So now, for number 1, the array is simply empty. That means nothing there. So now, the only way you can prove that, one way to prove that something is true is to show that you cannot find anything to prove that it's false. Okay, so now in this case, it will simply be true. Okay, so this is true because no counterexample, I would say E, such that E is a member of empty set, and it is not the case that P of E is false. You just don't have such thing. Okay? I don't want to go too much into logic, but if you get it, hopefully. But if you still got trouble, come to my office hour. I'll explain further to you. Let's apply the same logic over here. Now, number 2 hopefully is more straightforward. Now, so exist simply means we want to find at least one element that will satisfy the property. Now, in this case, can we find such element? No, you never can find one from the empty set, right? So this will be just false. So it will be false because no witness E such that E is a member of empty set and the property of P simply holds. Just not possible. So you will see that we got, so why is this important? Because empty arrays are often the base cases for your recursion on the array. So you really have to know whether that should be true or false. Okay? We're going to see that. Okay? We'll see both cases. And the way for you to judge is you want to know whether the property you're checking is universal or existential. Okay? Usually it should be quite obvious from the problem itself. Okay? Let's go back. If no question, I'll go back. So now let's see here. Determine if an array of integers are all positive. That's for all, right? For all integers in the array, the integer is positive, right? Now in this case, the base case should be empty array. In that case, you cannot find any negative number, so that should be true. Okay? Now in this case, is that true or false? True, right? Okay, that should be quite obvious, but you can get the idea. Now we can find at least one counterexample. In that case, that'll be false. Okay? That's kind of the idea. Now, how do we solve this problem here recursively? Let's try to see how we can do it. Before I show you the idea here, let's draw. Let's try to draw. Let me, first of all, use the example 1, 2, 3, 4, 5. How about that? Let's use that one. Okay, let's do this one here. Let's say we want to define is positive. Let's be more precise, is all positive. Is all positive over here, and then it's going to take integer array, some A. Okay? Let's say over here, let's think conceptually. I'm going to show you the diagram first. Let's say we consider 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Let's not worry about the indices just yet. Okay? So now you can see that, first of all, we have to somehow delegate a problem here because apparently this array is larger than empty array. We cannot solve them right away. So what can be conceptually the way you split this into a subproblem, for example? Can you think of it? Give me a subproblem. Well, yeah, that's good. Basically, what you were suggesting was, basically, you're considering, let me use maybe pink for things that you can delegate to your friend. What about considering this subarray over here? This particular subarray is strictly smaller, and we can delegate it to our friend. Okay? Now, in this case, basically, what we are trying to say is, we expect our friend to tell us the following. Is all positive, and then our friend is going to tell us if 2, 3, 4, and 5 is positive or not. It will tell us somehow. We can assume. The reason that we can assume this is because 2, 3, 4, 5 is strictly smaller than the original array, so we can assume that. Now, let's say they tell us the result, and in this case, that should be true. We know that, right? In this case, that should be true. Okay, that's not over, right? That means this returns true. Now, how can we combine this result with something that we're going to do from our side? We're going to do some work. What should we do? And statement, because, yeah, go ahead. Yeah, the first element in the array is actually above 0. Exactly. So now you can think of, let's use green to say that's the part that we can do over here. The green part is something that we should do from our side. The pink part is what we can assume our friend is going to do for us. In this case, we can simply say, again, let's say this is A. We can say A0 should be larger than 0. That's something we can do. So that's simple arithmetic. Combined with a recursive call to is all positive. And then that's the 2, 3, 4, 5. Over here, right? That's something we can do. Check the first elements and then delegate the remaining part to our friend. Okay? Are we okay with this? Let's do one more. How about that? For example, let's use another example over here. Let me say this. If I change this element over here from 4 into -1, let's see how that's going to affect the process. In this case, what's going to change? Is A0 larger than 0 going to change? No, right? Because 1 is still 1. So that means our friends, since we trust them, so we trust them that if there's anything that's negative in the subarray we give to them, they're going to tell us false. In that case, rather than having true, it's going to give us false. In this case, we have actually -1 over here, so that'll be false. So true and false, that'll be false, right? That's kind of the idea. Okay? Just one more. Let's say over there, let's say we still get 4 over here, and then, So which means our friend still give us true. And then, so this is still 4. Okay, let's say go back there. Let me just do one more. What if over here it is -2, the first elements? In that case, our friend is going to tell us that 2, 3, 4, 5, of course, is true. And then from our side, A0 larger than 0. That will be false. In that case, this part is going to return false. False and true will be false. Right? So you can see that it's all positive depends on both sides. So both sides are important. Okay. Okay, if no questions, yeah, go ahead. That's a very good question. The question was, since we are using ampersand over here, remember we talked about the short circuit effects for the conjunction, which means the evaluation at the runtime is going to go from left to right. As soon as, if we know that the left-hand side is going to return false, that means we do not have to bother to do the right-hand side. So now, when we do, I'll do one example with you. Yeah. So the recursion will actually, remember the right-hand side over there is the recursive call. So that means if we already know the current first element is already false, that means we're not going to make the recursive call. Okay? I think I should show you some example. Okay? I'll get there in just a moment. Okay? Maybe I can do that right away. Okay? Let me just do one more. Okay? Just for the first one, I think it's good to spend more time. Okay? Okay, let's say we do the following. If we want to do is it's all positive. All positive over here, right? And now, let's say, I'm just write a shorthand. Rather than array the curly brackets, I'm going to say just, actually, you know what? To avoid confusion. Let's say we got 2, 3, -1, 3. Let's say that's the array. So the final result should be false. Okay? Let's see how we can do this. First of all, this problem here is way too large for me to solve. So what I will do is now I can try the following. The first elements I can handle. The remaining part I'm going to delegate to my friend over here. So this is going to boil down into 2 larger than 0 from my side and is all positive, and then it's going to be 3 -1 and 3. So this is something I have to do. The evaluation is going to be from left to right. And this part here is simply just true. And because of the short circuit effects, that means we will only go to the right-hand side to call the recursion if it is true. It is, so we got to call the recursion, right? So now, we are now over here, okay? Because this is true. Now, our friend also finds this problem too challenging. So he is going to pass this problem here, was a sub-problem of this problem here, to another friend. Okay? So now, this one over here is going to be just the first element over here would be, the first element here, they can do it, and then this part over here, they got to delegate to their friend. Okay? It's going to be something very similar. So it's going to be 3 larger than 0 and is all positive, and then over here we got -1 and 3. Okay? Now, at this level here, are we going to call the recursion? Yes, right? Because over here you can see this part is true, right? So we go to the right-hand side. Okay? So now on this recursion here, our friend's friend found that this problem also is too complicated. So you can delegate to their friend, right? You just keep passing. Okay? That's kind of an analogy. So now in this case, what they will do is they will simply say, now they will handle only the first element there, and then they will delegate the remaining part to their friend. Okay? Now let's see what's going on over here. So now what we will have is -1 larger than 0, and then is all positive, and then simply just 3. Now, are we ever going to enter that recursive call? No, because, remember this is ampersand, simply because over here you can see that this is going to be false. Because of the short circuit effects, if the left-hand side is false, then you don't have to go any further. Now, imagine that if you got a very, very long array with 1,000,000 elements there. Now, if the negative elements happen in the very front of the array, so that means we're going to stop calling recursion and then just stop it right away. Okay? Are we okay with this? Okay. Any questions?
So the runtime for this worst case scenario is the size of the array?
Correct. I will try to make some connection maybe at the end. Okay? Because the way you can see that the way we're doing this is almost like running a loop. Almost like, going from leftmost until the rightmost. But we just want to solve the problem recursively. Okay? But now we haven't talked about how you can get a subarray. That's still left unspecified. I want to delay that discussion just a little bit more. Okay? So now, let me just talk about how we can do a subarray over here. Okay? When I say subarray, think about all the pink parts. You can see the first subarray we had to pass for recursion was 3, -1, and 3. The second one, -1 and 3. The third one, 3. Right? Think about how we can pass this subarray for recursion. One way to do it is we can simply create a new array of size, for example, 3, and then copy over 3 -1 and 3, and then pass that array to the recursion. And then when we go to the second level there, how do we create a subarray for -1 and 3? Create a new array, copy over -1 and 3, and then call the recursion on that particular new array. Keep doing this until we don't have to do any more recursion. But you can see that that's really, really inefficient because copying the array over, we know that it's very inefficient. It's a linear time operation, right? You're really wasting resources. And also, you also got to occupy the space for the new array, right? There's a much more clever way to do this. Let's think about how we can do it. Okay? Let me give you some idea. Okay? The way we're going to learn about how to do the subarray efficiently is by using indices. Okay? Let me just give you an idea over here. Let's say this is the original array. So we have 2, 3, -1, and 3. Okay? Let me just give you a little bit, let me just annotate this a little bit better. Okay? Let me say this part over here, let's say this is subarray number 1. Okay? And this part over here is subarray number 2. And this part over here is subarray number 3. Okay? Naively, we have to create separate new arrays for SA1, SA2, SA3. But we don't have to. Okay? How do we do that? So this is the original array, 0, 1, 2, and 3. The way we're going to do this is as follows. What's really SA1? SA1 basically is the array contents from indices 1, 2, index 3. Okay, that's from and 2. So this is basically subarray 1. I will show you how this works. But I'm just saying that I don't have to explicitly create new arrays. I just have to use indices to tell you these are the range of elements you have to consider. Okay? So what about SA2 in that case? It would be from 2 to 3, right? Okay? So now over here, in this case, SA2, it would be from here to the same element here, right? So this is SA2. Okay? So we are basically using the same array, but we're using different integer indices to tell us where we are. Okay? Okay, just one more, and then we'll see some code. Okay? Now over here, what about over here? Let's say this is SA3. In this case, what do we have? We have a subarray of size only 1. That means the from and to are the same index. In that case, that means the from should be, what? Who's Victoria? Wow, that's really bad, right? I don't know, maybe somebody using my computer as an air display or something. Anyway, that's not, okay, anyway. Victoria in the class, maybe? No? Anyone? Okay, anyway, that's fine, yeah. Okay, so now this is from, and this is to. So this is for subarray number 3. Okay, I know it's kind of difficult over here. Let me just summarize what I'm trying to say over here, and then we'll see some code and do the trace. Then you'll get an idea. What I'm trying to say over here is, when you see the conceptual tree over there, every time when we try to pass a recursion, we have to give a strictly small array. So there are two ways you can do it, inefficiently or efficiently. Inefficiently, you can just create a new array of that particular size and then copy over the contents and then pass that array. But that's too inefficient, wasting space, wasting time. Okay? So the way we do it is, we're going to say, now let's pass some extra parameters, some extra arguments. Every time when I make a recursion, remember call by reference. Call by reference means I don't have to copy the object itself. I only copy the address of the object. I will only pass the address of the same array over and over, like A over here, right? So I'm going to pass throughout my recursion tree only this array over here. That's A, only A. I don't create any new array. And then every time when I pass the recursion, I'm going to specify two more things. I'm going to tell this particular friend, this is where you should start from, and this is where you should start until, from and to. So the from and to tell my friend, this is a subarray you should really consider. Okay? There's a sub-range. Okay? You can see the from and to. So in the blue one, correspond to the biggest subarray, number 1. So from would be 1, and the 2 would be 3. And then the red one over there, which is subarray 2. In that case, the from is larger. In that case, we shorten the range of the indices our friend should consider, right? So that would be, from would be 2, and then 2 would be 3, etc. Okay, let's see if you got about 30–40% understanding. That's good enough. Let's see some code, okay? Because there are actually quite many pieces that should work together for this particular strategy, but we'll get there. So now, what I want to do is, let's go over the strategy for allPositive first, and then we'll see some code, and then I'll trace. Now, empty array will simply just return true, and we explained that logically already, okay? Now, what about recursively? Recursively, what we're going to do is, if the first element is positive or not, combined with if the rest of the array is also positive, right? So you can do some extra exercise. Let's say if I change is all positive into some positive. In that case, how should you modify the base case, right? And the rest. That'll be an exercise for you. Okay, so now making recursive call on the array. So this will be the slide I just mentioned that. I'll just skip that for now, okay? What I will do is, let's see the code and then we'll trace. Let's say we want to define this method here, allPositive, and it's a Boolean method. It's going to take an integer array of name A. How do we do it? Let's see this. This is a new pattern you have to learn. It's not too bad. So we define the so-called recursive helper method. What does that mean? That means we're going to call another method there, and the method we are calling is recursive. And the method is going to do what I said before. Rather than passing just the array, we're going to specify two more things. We're going to tell that particular helper method from where to where in the array you're going to consider as a subarray. Okay? So now you're going to see that we have, so convention is we simply say whatever the method name is and then append with helper. So allPositive helper over here. So you can see we pass the reference of A. So that's call by reference, right? So we are not really making any new copy of the array. We're just passing its address. And then we say that for this, so to start with, you're going to consider the entire array, which means starting from 0 until the last index. So that's the entire array. But you will see that when we are making recursive call, every time when we want to solve a smaller problem, we have to increase the indices or decrease the indices. We'll see that, okay? To shorten the range to be considered. Let's see how we can define this helper method here, and then we'll trace. So now you can see that is positive helper over here. It takes 3 arguments. It takes an array A, and then from, and then to, right? 2 indices, right? So this is really the key. So this is how we make our recursion efficient. So we do not pass any new array objects anymore, simply just the indices, the from and the to. So now, when from is larger than 2, I'll show you in one example in just a moment. From, let's say, if you say, for example, let's go back here. Just make some very quick connection. Let's say if I want to consider the entire array over here, I should say from 0 to 3, right? So now, eventually, you will get to the cases where maybe the from is not really larger than 2. The from is not really smaller than or equal to 2. It might be the opposite. That would mean empty array. I will show you. Okay? And then, if from is exactly equal to 2, that means we're considering just single elements in the range. In that case, we can simply just say if that particular element we're considering is larger than 0 or not. Now, what about recursive call? Recursive call means we'll simply say the from element, or like the first element we're considering in this current range, is larger than 0, and also allPositive helper. That's a recursive call. So now, how can we specify a strictly smaller subarray? Used to be from, but now we say from plus 1. So that means we are making the pointer to the right by 1 position. So that means we're considering a strictly smaller range. Okay, any question about the Java syntax here? The idea, I'm going to explain it to you. Okay, any question before I move on to tracing it? Yeah. So say that again. You cannot read the. So, okay, you know what, we'll actually, how about save this question here? There's some cases where we simply just, we may actually have that case over there. Yeah. From larger than 2 is simply some special cases where the range we're considering is simply just empty. Okay, we'll get there. Okay. Okay, so now let's see what we can do. Okay. Now let's see how we can trace it. Okay. So what I will do is let's go back to iPad over here, and then let's see how we can do it. Okay. So that's the code. That might be a little bit too big, maybe. Let me just make it a little bit smaller. Is that still readable? Like that? Okay. And I want to move it a bit up, like that. Okay, that's good enough. Okay, let's see how we can trace. Let's do something very simple to begin with. Okay, let's say we do this. If you say allPositive, I'll say all P, okay? allPositive, let's say we are considering an array. Let's say, let me put an array over here. Let's say array A of only 3 elements, only 3. 0, 1, and 2. Okay, let's say I got 3 here, 2 here, minus 1 over here. Okay, only that. Okay, so now if I say allPositive and then I simply pass A, okay, what does it do? What it will do is it's going to call this recursive helper method. Okay, what it will do is it's going to say allPositive helper. It's a different method over there. And then it's going to say the same array A is a call by reference, only a copy of the address. And then it's going to be 0 and then A.length minus 1, which is 2, right? So that means the initial recursive call, the initial call to this one here tells us we should consider this array here from 0 to 2. Okay? So now let me just use blue over here. From and 2. Okay? So now, what are we going to do for this particular call? So now, when we say, is from larger than 2? 0 and 2, right? They are not, right? From is smaller than 2. Is from equal to 2? No. So we should go to this line over here, right? So we should return a from, which is, you can see from, this is from, right? And this is 2. A from is 3, right? So what this will do is A 0 larger than 0, and we're going to make a recursive call. And then we're going to say allPositive helper. In that case, let's be careful over here. The same array A. And then from plus 1. From is currently 0. 0 plus 1, 1. And then we have 2 over here. So what does that mean? That means when we are making a second recursive call, that means now that particular recursive call is going to consider a strictly smaller range. They're going to consider 1, 2, 2, like a subarray over here, right? You can imagine that, right? If you want me to make it even more colorful for you, the first one, blue, is going to consider over here. And the second one, which is red, is going to consider like that. Okay, from and to. I'm not sure how much more visual I can make it be, but hopefully that's good enough. Okay. Now, over here, let's try. What's over here? A0 larger than 0. True, right? A0 is simply just 3 over here. So that's true. And now, what happened to this particular recursive call? So now let's try. So now from is 1 and 2 is 2. Okay, so now what should we do? Are we reaching the base case? First of all, is from larger than 2? 1 is not larger than 2, right? Is 1 equal to 2? No. So we should go to the else part. In that case, what we will do is, let me just say, so let me use a different color here. So the tree should kind of expand from here, okay? Let's try that, okay? So what we should do is, we're going to say A at position, in this case, from is 1, so A1, okay? A1 and we should make a new recursive call, right? So now, over here, we're going to say from plus 1, and all positive helper, the same reference to the same array, okay? And then over here, what should we put over here? From plus 1, right? 2, exactly, because now the from we're talking about is simply just 1. So that will be 2 and 2. Now, let's see. So now let me just, so that will be 2 to 2. So that means over here, 2 and 2. So this will be from, and this will be 2. So that means the final range we're considering simply just over here. Okay? Now, let's think about what happened to this particular recursive call over here. What happened to it? So now, from is 2, and 2 is 2. So this is from, and this is 2. What happens? So is from larger than 2? No. Is from equal to 2? Yes. Now we're reaching that case where the range we're considering is has simply just one element. You can see, in this case over here, we are considering range rather than subarray for efficiency reason. Okay? It takes some time to get used to. Yeah, let me just finish this and then we'll talk about it. Okay, so now we do have this case over here. So what we will do is we'll simply return. Return if A from A2 is larger than 0. Okay, because from is simply just 2, right? So now let's try, let me use a different color to make a conclusion over here. So now, is this true or false? A2. This should be false, right? Because A2 is minus 1. Okay, so this is false. But now we're going backwards, right? And now, what's A1? Larger than, sorry, there was a little bit typo. That should be A1 larger than 0, right? Okay. Now, so now we know the right-hand side for the short circuit, but short circuit only work when the left-hand side is false. So we're going to continue, right? So now, what about A1 larger than 0 over here? A1 larger than 0, 2 is larger than 0. In that case, what we have is true. Okay, so now what do we get? True and false, we get false. So that means for this particular recursive call over here, we got false. And then A0 larger than 0, we know that it's true. True and false, false. So that means overall, this method over here gives us false. And then you will return back to all positive A, false. So that gives you the correct result. Better for from and to. Okay.
So to clarify, this is just so that you don't touch the array, like you don't modify.
You don't really modify the array, that's correct. And also you do need to create a new array
Yeah.
to actually pass around the recursion. Guys, any question about this particular pattern here, how you use the from and to? Any question? Yes?
This
Yeah. Very good question. Why don't we try? Okay. The question was, first of all, you should notice that the short circuit effect is useless in this case because the false happens on the right-hand side. But the short circuit effect only occurs when the false occurs on the left-hand side, right? Okay. It's a good question. Why don't we try very quickly? Okay, let's try again. Okay, let's try. Okay, so now if I say is all positive over here, let's say get something similar. Let's say 3 minus 1 and 2. How about that? Okay, 3 minus 1 and 2. And what this will do is it's going to pass to the recursive helper method over here with 0 and the length of the array minus 1, the largest index, right? So it will do, I would say, okay, all positive helper. In that case, it's gonna, okay, so of course this is A, right? Because it's gonna be A, and also we got 0, A dot length minus 1, so that'll be 2. Okay, so also good? Okay, so now let's try that. So what this will tell us is, we're going to do the following. We're going to say A at position 0 is larger than 0, right? Because, right? And then we're going to make a recursive call. Now, all positive helper, what do we do here? Test your knowledge. What should we do? 1 to 2, right? Good, very good. Not too bad. 1 to 2. And then, so now this part over here, you can see that from left to right. So this one is true. Agree? A0 is 3, which is true. Okay. Now, what about this part here? You can see we are not reaching the base case yet, so we still got to make a recursive call. So what this will do is we're going to say A at position 1 larger than 0, and also make another recursive call. A, what happened now? Oh no, I'm just saying, how do I continue the rest? 2 to 2, right? Okay, because from plus 2, right? Always remember, that's how you make a recursive call. Okay, that will be 2 to 2. Now, here's the thing. As you asked in your question, now you can see that the negative elements happen in the middle, index 1. In that case, that means over here, this is going to be false, right? So that means we don't bother to execute this recursive call at all. Doesn't matter anymore. So what we will do is, this part over here is going to be false directly without even evaluating this particular part. Okay? Hopefully that answers your question.
So it's like a short circuit rate.
Exactly. The short circuit actually in some ways is for efficiency. As soon as you reach the first false, it's going to stop. But if you're unlucky, let's say the false happens at the very end of the array, then no way, right? Yeah.
It's like
Empty array, yes, the empty one. So now here's the thing. Think about this case. Very good question. I almost forgot. Okay, let's go back to the code over here. Okay, I think the code. The question was, why was this part here necessary? Okay, this one's a bit tricky. Okay, it's actually very easy. I'll tell you right away. Okay, let me use a color over here. Let's try to make some example over here. Okay, let me just put it. Okay, new page. Okay, let me just refer to the definition here. All positive. Let's say A. Let's say I simply say integer. A is new. Integer, I'll make it explicit, empty array, just empty. Okay, I'm passing A over here. So what's going to happen here? What it is going to do is it's going to call the helper method over here with 0 and A.length minus 1. Okay? In that case, it would be all positive helper. The same reference A, and then 0, always the same. What's A.length minus 1? Negative 1. Now you have from is less than 2. Oh, sorry, from is larger than 2. Sorry about that. From is larger than 2, right? So now in this case, you have the from is larger than 2. So that's the special case for empty array. Yeah, that's a base. That's a base, exactly. Yeah. So this is empty array. Yeah, question. Good question. Good question. Yep. The question was, another way to do this, which you can feel free to try. Another way to do it is, let's say you don't quite like that from larger than 2. Maybe it's not so intuitive to you. You can get rid of it. Okay. Let me show you. Otherwise, you get confused. Okay. Let me add a new page and then illustrate that exactly. And then I'm going to add that particular method here if I can find it. Okay. I think it should be. Okay, I'm lucky. I chose the right one. Good. Okay, now how can we change this one here? What I can do is, let's say I'm not very happy with this. Let's say I want to get rid of this. You may get rid of else over here, right? And then all you got to do is you can do the following. Over here, you can say if a.length equals 0, return true. Yeah, and then you got the rest. This will work too. It's kind of up to you because I think that the way I presented this is kind of easier to see mathematically. You can see you always try to make this particular call with 0 and a.length minus 1, so you can treat them uniformly, right? You also always got 2 integers. When the from index is larger than 2, that means it's empty, right? It's more mathematically elegant, but you can definitely do that one. Okay, any question about it's all positive? So that's the very first example on array. So we've still got about, well, roughly 15 minutes, a little bit less. We can definitely do more examples. So if you don't have any question, I'm going to go to continue. Okay, you will see that many examples are very similar. We're going to play with from and to. Okay. Now, what about this one here? Guys, your exercise, don't forget, your exercise is, oh, by the way, so over here, this slide here now should make sense to you. I'll leave it to you. This one simply says how we go from the naive solution where we create explicitly the subarray into the from and to ranges. Okay, you can read this slide. We have got this covered already. Okay, now your exercise, don't forget, I'll remind you over here. Your exercise is you should write a method which is some positive rather than all positive and try to make it work. Okay? Now, let's talk about the next one. Now, we want to know, given an array, we want to know if it is sorted in a non-descending order, which means you kind of sort increasingly. Okay? How do we know that, right? This can be done in a very similar way as the previous one. Okay? So let's think about the idea. Okay? So let's think about the idea. Let me move back to Pat over here. So now, okay, I don't want to show you the code just yet. So why don't we just have a new page? So now if I have is sorted, and this is going to take, of course, it's going to return a Boolean. And then it's going to be integer array A. Now, try to think about how you can solve them, okay? Base cases first. Base cases. Anyone? Base cases? Empty array, true or false? Why true? True is correct, but why? No counterexample. What do you mean no counterexample? Let me be more specific. In this case, why?
Well, if there's nothing there, you can't find something that's not sorted.
Exactly. That's exactly correct. So basically, in these, how can you find a counterexample? A counterexample means you find AI and AI plus 1. They are not sorted. right? They are not really, it's not the case that AI is less than or equal to AI plus 1. If you can find one such pair, then it is not sorted. But for empty array, you cannot find such pair, no way. Okay, that should be true. Okay, empty array, we know that is true. Okay, what about something that's larger than empty? Now let's think conceptually. Okay, let's think about it. I will help you guys and then I'll let you answer. What about, let's think conceptually. Let's say index 0, and then this is the remaining array. You can even mention color if you like. Let's say first one, and then that's the remaining array. Okay, hopefully that gives you a lot of hints, right? Now, any idea? You can see the way I split the array is pretty much the same as before, right? First elements, the remaining of the array. Now, how do we do that? Question first. We're going to use it. I tell you what, the from and to, they are somehow very implementation specific. They're just about, for efficiency reason, we are specifying ranges of the array rather than subarrays. But now, conceptually, we don't have to think about from and to. We'll get there. Okay? So now, let's say if I can split the array into green and pink, right?
So we see if the green is larger than isSorted of the thing.
Well, actually not quite, right? Remember, okay, let me ask you this. So now if the pink one is actually the subproblem I'm dealing with, so that means over here, my friend can tell me that isSorted over here is going to give me the pink array over here, right? It's going to be either true or false. You were saying something like compare these two. You're saying if the green one is smaller than the result, but what its return is true or false. How can you say, you see what I mean, right? But you're getting somewhere. You're getting somewhere. Let's say if my friend can tell me that if the pink part is sorted or not, what should I do? What should I do? Aha, right, exactly. Because to know that if the very first pair is actually sorted, I simply got to compare the green one, which is the first element, and the second element. That's what I got to do, right? That's kind of conceptually the idea. Okay? So what I would do is I can simply say something here. I can say something like A0 less than or equal to A1. That's my part, and then combine this with my friend's result. Okay? That's conceptually, right? Any idea, any question about this concept over here before I move on to some Java code? Okay? And we can try to trace it as well. Okay? Okay, let's see how we can define the Java code. It's not too bad. Okay, we talk about, okay, this one is easy. So now empty array, true. Now let's see how we can define the problem. If the array is not empty, what do we do? Okay, so somehow, as you said, the green one and the second elements, right? The green one and the first element in the pink. So first of all, the first and second elements are sorted, and also the rest of the array, starting from the second element, is also sorted, the pink part. Okay, so we're going to combine these two results together. But now, what do we do? How do we do it? Okay. Okay, let's see the Java code, and then we'll try to trace it. Okay. So now, how do we define this? It's sorted. Okay. Let's now make a recursive call to the helper method. So we'd say it's sorted helper, and then we're still going to consider the whole array to begin with. So that'll be from 0 to a.length minus 1. You can see this part is almost identical to as before, except for the method name. Okay. Now, how do we do it? You will also see that from larger than 2 is again the base case, which means empty array. The reason is as before. If from is larger than 2, return true, because you cannot find any counter example. If from is equal to 2, that means a single array, a single element subarray. In that case, is it sorted? Right. If I have an array with only 2 over there, it's sorted. Again, you cannot find any counter example. Now, let's see how we make the recursive call. I simply say, whatever from I'm dealing with right now, compare the from with the next element, which is at index from plus 1. That result is going to be done from my side. And then make a recursive call. And then simply say from plus 1 and then 2. Okay? That's how we do it. Let's do one example, shall we? Okay. Any question about the code before I move on to some tracing? Okay. Okay, let's do some tracing. Okay, over here, I think I have that. It's sorted over here. So now again, I want to make it smaller. Edit. Okay, like that. Good. Okay, let's try some small array so you will just get an idea. Let's say this. If I say is sorted over here, let's say I got an array over here. Let's say it's simply just, again, 3 elements, 0, 1, and 2. Let's say something that's sorted, right? If you got false in the middle, you also, of course, you also return false. Let's say it's 2, 3, and 4. Okay? So now it's sorted over here. We say A, and then we're going to call the recursive method for the first time. And then we're going to have is sorted helper. Okay? And then we're going to have A, and for the first time we call that, we're going to consider entire array. 0, and then A the length, 3 minus 1, 2, 0 to 2. So that means from 2. Over here. Okay, the first time. Now, let's try to see how it is going to work. It's very similar as before. Now, what it's going to do is from is 0, 2 is 2. So 0 is not larger than 2. And also 0 is not equal to 2. So we go into this case over here. We're going to return the following. We're going to say A from is 0 less than or equal to A from plus 1, which is 1. And over here, make a recursive call. Is sorted helper. What do we have over here? Help me out. A, 1 and 2. Very good. Thank you. So now you can see that over here, what's A0 less than or equal to A1? True. Very good. So we should continue. Okay. So now over here, you can see that. So now we got new from and new 2. So now let me use here. So we got 1 and 2 over here. So that means okay, let me use green. It's simply just 1 and 2 over here is a subarray over here. And now let's see what's going to happen. Now, so 1 and 2. So now we are making this call again. So now 1 is not larger than 2. 1 is also not equal to 2. But so now we go into this case again. Okay. So now what do we have? What we have is A1 less than or equal to A2. And then, and also what we have is making another recursive call. And what do we have? A to 2. Good, thank you. So now what we have is over here, so we have 2 and 2. So I'm going to highlight that. So 2, 2 over here. Okay, so now for this particular one, what's going to happen? You can see 2 and 2. So now 2 is not larger than 2. So this one, no. 2 is equal to 2. So return true. So that means this part here is going to return true. And what about this one over here? A1 less than or equal to A2. Okay, over here, that's 3 less than or equal to 4. So that's true. True and true is going to make this part over here true. And then we know that this is already true. True and true is going to say this part over here is going to be true. And then it's going to return true to here. So finally, it's going to be true. Okay? Guys, any questions? Okay? Now, I'm going to pause or stop here, but I want to just spend 1 minute to tell you what you should do. Okay? For those of you who don't have to prepare for lab test for Thursday, go over the way we do from and to indices up to now, and then on Thursday we're going to go over another 2 examples. We're going to do sorting, and also we're going to do binary search. So these are more challenging, but if you understand from and to, you should be able to understand. Okay? See you on Thursday.